Yesterday we looked at combinations, which is an arrangement where order does not matter. Today we're going to take a look at permutations, which is an arrangement where order does matter. So for example, electing positions, that's an arrangement where if you elect somebody as president, then they can't be elected as vice president. So the order in which you elect people does matter. We're also going to take a look at what's called the fundamental counting principle. So that's actually our first vocab term. And this just says that you multiply all of your options together to get your total number of options. A really common example is how many outfits can you create if you have, for example, 3 pair of pants and 5 shirts from which to choose. You would just simply multiply the 3 times 5 together and you would have 15 possible outfits. Now, no one says those outfits would actually work well together, but that's how many outfits you could create. All right, now looking at the permutation formula, similar to the combination formula, except there isn't that additional r factorial in the denominator. It's simply n factorial over n minus r factorial. Again, n is the number in the group, and r is the number of items we are choosing. So we're going to take a look at the fundamental counting principle first, really quickly, because it's quite simple and straightforward and easy to use. So we've got this lunch special menu. We have 3 possible entrees and 3 possible side dishes and 4 drinks from which to choose. 9 times 4 is 36 possible different lunches that we could create. Next, we're going to take a look at a couple of examples of permutations. So our first example is how many ways can 8 people finish a race? So in this case, we have 8 people in the group. The order matters. First place obviously is very different from last place. And we are choosing all 8. We're assuming all 8 will finish the race. So 8p8. Let's look at the formula real quickly. There is a way you can do this on your calculator. You probably already found it when you found the combination button. But to show you, initially when we looked at factorials, we talked about 0 factorial is defined as 1. And this is why, in the case of a permutation, if you are choosing, and a combination, if you are choosing all of the items in the group, you will end up with 0 factorial in the denominator. So we have to define 0 factorial as 1 in order for this to work. And I'll show you another way to think about this question as well. So 8 factorial is 40,320 different possible ways for people to finish the race. Another way to think about it is there's 8 people that could finish first. After somebody finishes, there's now 7 people left for second place, 6 for third, 5, and so on, which is 8 factorial. So thinking about it the 2 different ways, they have to be equal to each other to get the same number of outcomes either way. And our final example, how many ways can you elect a president, vice president, and treasurer out of 6 people? So we have 6 people. Order matters. Once you're elected president, you cannot be elected vice president. And we are electing 3 people. So 6p3, 6 factorial, over 6 minus 3 factorial gives us 6 factorial over 3 factorial. So when we expand that, we have 6 times 5 times 4 times 3 factorial, which will cancel with that 3 factorial in the denominator. 6 times 5 times 4 is 120. Again, another way to think about this one, permutations, you can think about it kind of logically, whereas combinations with that additional r factorial, you really have to use the formula. There's 6 people from which you could elect president. After the president's elected, there's 5 people left that you could choose to elect vice president, and then 4 people left to choose the treasurer. And here are your try questions.